Assalamualaikum and hello. Let's continue with our new chapter, chapter 8, where we are going to learn about chemical equilibrium. In this first subtopic, you are going to learn about reversible reaction and how to state the characteristic of dynamic equilibrium system and law of mass action. And last one, you have to interpret the curve of concentration reactants and products against the time for a reversible reaction. In this video, we are going to focus what are reversible and non-reversible reactions. Let's go to non-reversible reaction first, ataupun another term we can use as irreversible reaction. Usually, our chemical reaction memang akan proceed to completion. For example, we have A plus B will produce C plus D. So this is our reactant A and reactant B, product C and product D. This is how the chemical reaction usually happen, and the reaction will continue until one of the reactants is completely used up, and that reaction will stop. And that reactant yang completely used up, we call it as limiting reactant. And this reaction only takes place in one direction sahaja. For example, I have 2 KClO3 in gas phase to produce 2 KCl solid phase plus 3 O2 in gas phase. So this is how the reaction happens in one direction only. However, in another case, we got reversible reaction where some of them do not proceed to completion. It means that not all reactants are changed to product because the product can dissociate back to form the reactants again. And this is why this kind of reaction takes place in both directions. For example, I have reactant A reversible with product B. So what will happen from reactant A to produce product B, and we call it as forward reaction. For the second part, product B can dissociate to form reactant A back, and this is what we call as reverse reaction. When a chemical reaction takes place in both forward and reverse reaction, we call it as reversible reaction. And as you see here, the sign for the arrow is quite different, which is you have to write it down like this. Bukan dalam satu arrow just like this one. This one is not acceptable for reversible reaction because this is only for non-reversible. So please take note when you want to write the chemical equation in this chapter because we are talking about reversible reaction. For example, reversible reaction can happen between H2 gas reacts with iodine gas, reversible to form 2HI gas. And this is what we call as reversible reaction, where you can see the arrow like this one. So how you want to describe this kind of reaction in terms of sentences, you can say that in reversible reaction, initially reaction will move in forward reaction to form the product, where these two reactants, H2 and I2, will react together to form HI. This is forward reaction. But as soon as some product molecules of HI form, the reverse process begins to take place, where the reaction will dissociate to form the reactant molecules back from this product. And in order for you to indicate by using the correct sign of arrow, you will use as reversible sign for this arrow, just like this one, if you want to write it down in your answer. So this is the concept of equilibrium that you have to know. There are two of them, reversible reaction and non-reversible reaction. For reversible reaction, it will go both directions. And you have to know non-reversible is the opposite of that. It will proceed in one direction sahaja. The next one, for non-reversible reaction, reaction only proceeds toward to form the final product, and one of the reactants will completely consume up, and this is where you have to know that the reaction will stop at one certain point. However, for reversible reaction, as soon as the product molecules are formed, the reverse process will take place where the product dissociates to form the reactant. And you have to know that their sign for the reversible reaction is just like this one. However, untuk non-reversible sign, macam biasa, we write it down like this one. So that's all for this video. I hope so far you understood what's the difference between reversible reaction and non-reversible reaction. I'll see you in the next video. Bye!